mask the sound. And so I said, well, before we're going to do this, we're going to sit down and talk about the right questions. You need to ask me. And yeah, so it made a difference. It was a woman, female. I don't remember who it was. It's been a long time ago.
Okay, I'm rolling.
Okay. All right, here we are, Mike.
Okay.
Tell me your title first.
Okay. I'm Division Chair of Engineering Technologies.
Okay, Engineering Technologies here at OSUIT has several programs underneath. Can you kind of list them out?
Sure. We have Civil Engineering Technology, and as a subset of that, we have Surveying, and then we have Engineering Graphics and Design Drafting, and we have Manufacturing Technology, and we have Power Plant Technology, we have Nanotechnology, and we have Electrical Electronics, and then that spins off into a Bachelor of Technology in Instrumentation. So we have a very diverse bunch of programs here.
Okay, well, let's start with Civil Engineering,
Okay.
which is like one of the oldest, I know, second to the military engineering, I guess it is.
Yep.
Just, that's such a broad definition. Can you kind of define that? What is
Sure.
a civil engineer?
Sure. Civil engineering as a program deals with essentially the elements of nature, and that have to do with building dams and roads and bridges, and they deal with dirt and all of the different physical properties of the earth, and also concrete. And they start studying the basics of physics. They do statics and dynamics and strengths of material, and it's a probably the most fundamental engineering program there is.
And you know, that's such a, I mean, there's always going to be jobs in that. Can you kind
Absolutely.
of talk about the demand?
Sure. I'm sure we all read in the newspaper that our bridges are deteriorating in this country, and our whole infrastructure, our water system and our sewer system, and that's all civil engineering. So if a young person was interested in that particular discipline, I think they could be assured full employment for a long time. One of the things that our new president has talked about is a stimulus package and spending a lot of money on infrastructure, because it actually benefits everybody in society. We all like to have safe bridges and smooth roads.
Right. And as a program here at this Institute of Technology, why would someone want to go to OSUIT for civil engineering as opposed to another school?
Well, when we talk about civil engineering here, we have one more word involved in civil engineering technology. It's very different than civil engineering at a four-year comprehensive university. There, typically, students are more interested in the design aspect. And in all of our programs here, the students come here because they want to put their hands on something. They either want to run the survey equipment, or they want to do a proctor density test in the field. They actually want to do the application of that engineering discipline, and that's what sets us aside.
Can you kind of just a little bit more delve into the theoretical as, the application based and the actual hands-on, and why do you think that would benefit them in the future?
Sure. There's not much gets done in the world, any place, until somebody actually physically does something. And I mean everything from dig a ditch to pour a bucket of water. And we don't dig ditches and pour buckets of water, but our students are typically more engaged in things that they can touch. And so we teach the same disciplines. If you went to a four-year university and took statics, we're going to teach you the same thing. The difference is how we teach it. We're going to teach it in an applied manner, and we're going to actually do experiments, and you're going to see how it actually is used in your discipline.
Can you kind of comment on
Hold
it?
on just a second, I'm sorry. We're getting some popped P's and T's. I'm going to change his mic location just slightly.
Okay? I hate to pop them P's and T's.
I know.
I know.
And don't tell him I said this, but Roger, his S's are whistles.
He almost has a speech problem. He really does. Yeah, I noticed that.
Very,
Yep.
And can you kind of touch on the interactive aspect makes it fun for the students?
Sure, you betcha. Yep.
Good experience, enjoyable.
Yep.
And then
Well,
also,
let's talk about for a minute the whole, and you can edit this back in, but the whole atmosphere here is very different than any other university. We don't call ourselves professors. We don't talk about colleges and university.
that's awesome. Hold it.
Yeah, we'll have that whole conversation.
Yeah, I like that.
Okay. Thanks, Lonnie.
No problem.
Thank you.
Okay.
guys have a good day.
Do I get final approval of the picture?
You did on the last one, didn't you?
Yeah. You know why? Because I was adjusting the mic,
Uh-huh.
but Jennifer was there, and she was like, like it looked like I
Like,
was
what are you
jamming
doing
for
to
it.
me?
That's why
How dare you touch me?
And on this campus, they would all like, oh.
Exactly, yeah. Yeah, in Stillwater, you'd have 100 volunteers, you know.
Okay, I'm
Okay,
rolling.
So what? How's the atmosphere different here?
Well, we're just different in our structure. When I recruit, one of the first things I talk about is the fact that on any given day, you're going to look up and probably see the president of our university wandering around his campus. He is very connected with the students. We're absolutely student focused. 40-some% of our student body are attending college for the first time. Nobody in their family has ever gone to college. So we've created, and I say we, and I don't have anything to do with this, we've created an atmosphere here, though, that is very different. We don't call ourselves professors. We don't say this is the College of Engineering. This is a division. The instructors have tremendous rapport with their students. They know them all by their names. The students are pretty welcome to call the instructors anything. They call them Mr. Taylor, or they can call me Mike Taylor. But that kind of collegial atmosphere is across campus. And the reason we do that is we feel like that leads to a much more relaxed learning environment, and it enables our students to be more expressive and to be themselves. And I can get to know you as a person, and then I can learn your learning styles, and it helps me as an instructor to be more effective. And we all understand that everybody comes here that has a primary learning style of doing. They like to touch and feel and interact. But they also have to listen to lectures a little bit, and they have to hear, so it just makes us more effective.
Can you tell, and I had the teachers touch on this, but you know, those calculus problems
Yep.
look so hard, but they've actually devised a way to get, you know, like a real world example helps them.
Exactly. Our calculus instructor here has almost daily conversations with the faculty. She's not an engineer, she's a math professor. But our students learn when they understand that what they're learning is part of what they're going to be doing, and we can show them specific application right now. And so everything that's taught in calculus, the students come back to this building and actually put their hands on it and do it. We also have it's structured, but nobody gets paid to do it. It's all done on a volunteering basis. Our faculty meet with our calculus students outside of the faculty class on everybody's free time and talk about the application of what they learned in calculus that day or the day before. And it just makes a total difference in how well the students learn and how easily they learn a very difficult subject.
Yeah, and it is difficult, but you know, fun is one of the words that is your buzzword
Yep.
throughout your presentation.
Absolutely.
Can you just kind of use that in a way to explain that that's what it's what you want it to be here, and the students do have fun, and it's an enjoyable experience.
Absolutely. Our philosophy is that if we make stuff interactive, then it's going to be fun. If you get a chance, you have to endure my 10 or 15 minute lecture, then we're going to go spend 45 minutes applying that. That's fun. And we don't look at this as rocket science. I mean, we all, even the instructors, enjoy what they're doing a lot, and that comes across. You can see that in the classroom, and you hear a lot of laughter, and that's something we're a big believer in. We'd like to keep it very informal so that it can be fun. And we have lots of cool toys to play with, and that's always fun.
Let's talk about that.
Sure.
The sponsors' involvement and commitment and.
Yep. One of the things that this institution, for its 60+ years of being, has developed is a tremendous relationship with industry. Every year we have 2 industry advisory board meetings, and we bring in industry to help us stay focused, and that really is what we do. As the pace of technology has sped up, that input has become more and more important to us. 50 years ago, technology didn't change a lot. Today, from the spring advisory board committee to the fall, we may have had a huge technological breakthrough, and we have to talk about that. How is that going to impact us? One of the things that's happening in industry, in the electronics world, is everything's becoming wireless. Years ago, we strung miles of wire to hook all this stuff together. Today, we use something similar to cell phone technology. That's something new to us. So we have to incorporate that in what we teach, and also we have to have that equipment so that the students can learn to use it.
Can you kind of talk about how this equipment that's available on campus, just campus-wide in every program, is paramount for them to get this, and that the commitment of the sponsors donate it?
Yeah, industry. The uniqueness of our graduate to industry is that they can graduate on Friday and go to work on Monday and be productive. They don't have to go into a 1 or 2 year training program at some industry. They can literally go to work Monday morning and be part of a team. And to have them with that set of skills, we have to have state-of-the-art technology. And so we can't afford all of it. I mean, there's a lot of things that we would love to have that cost $100,000, $150,000. Our industry partners donate that kind of equipment on a continuing basis. Now, it's really nice of them to do that, and we appreciate it, but realize it's also self-serving, because they're going to get to hire employees out of our programs that they can put to work on Monday morning. So it's a symbiotic relationship, and it's one that's lasted for a long time and will last into the future.
That's awesome.
It was.
That was good.
I heard that magic.
We're not done yet, buddy.
5 more programs to talk about. Well, you've done what I thought that would be helpful for all of the programs under ET.
Okay.
But specifically, let's at this time.
Sure.
Kind of go through each one and the best parts of it to showcase. Like, so in civil engineering, they have a few really, really awesome toys.
Okay, sure.
And just talk about that and the experience the students get there.
Okay. Civil engineering, on this campus we have 2 paths. One of them is the civil engineering technologists, and they're gonna talk about concrete and rebar and soils and measuring all that. We also have all of the tools to teach them to do that with. They can measure the slump in concrete. They actually have a lab where they mix concrete and they pour it into the little cylinder, and they release it and they measure the slump. They also learn to measure the strengths of the concrete. They pour the test cylinders and break them 28. We have all that equipment. And the second path in civil is surveying. And the surveyors work hand in glove with civil engineers in the real world. And we have total stations and data collectors, and we have a GPS. All of those words are for high-tech surveying equipment. The day of the surveyor with the chain, and I used to measure land by chain links and rods. Those are all gone. We're using satellites, and we're using computers and computer technology, and it allows us. All of this technology allows us to do all of the work that's required with fewer and fewer people. But those fewer and fewer people have to be smarter, better educated, and able to use all of this high-tech equipment. The design drafting, engineering graphics and design drafting program is all about computers. It was kind of interesting when we started out years ago. We did CAD/CAM, computer-assisted design, computer-assisted manufacturing. And we had some kind of clunky old machine tools that were big. We did used almost coordinate geometry and did some programming, and then the machine would make a part over and over and over again very accurately. Other places discovered all of this. Now we use computer-assisted design in architectural. It's used across every discipline. Almost everything you do in engineering world today starts out with a AutoCAD drawing. So our engineering graphics and design drafting people get a thorough bath in that world. Now, what's interesting is we're moving into a whole new era in that discipline. There's a product out there called Revit. It's an Autodesk product. Autodesk owns AutoCAD. Revit is a 3D design tool. It's being used in the construction world by architects to create what's called building information modeling. And they take a 3D drawing and they overlay that with an accounting package that shows the expenditure of funds as a building's built. And then we overlay that with a scheduling software. So on a computer screen, we can watch the building being built. We can watch how much money is being spent in the lower left-hand corner of the screen and how many days it's taken to do all of this in the right-hand corner of the screen. So this whole technology just keeps exploding. Right across the hall here from design drafting is our manufacturing technology lab. We have state-of-the-art equipment in there. And the reason that they're situated that way is because the design drafting students in their AutoCAD classes are learning to do drawings that can be sent electronically across the hall to those big machines and make parts. And so they can look out those big windows and see all of that happening in a real-time manner. So the students in the design drafting not only could do architectural work, they could also go to work for any kind of a manufacturer and walk right in and work there. The students in the manufacturing technology have to work in the real world with their design drafting counterparts, so we have that set up in our classroom. That's how it works. The manufacturing technology, that whole world of manufacturing, even in this economic slowdown, those highly skilled technicians are in high demand.
Can you kind of give like a brief, like a broad, like a basic definition of manufacturing?
Sure. In the world of business, manufacturing has two components. One of them is fabrication, and the other one is we use these machine tools to make parts. We do the machine tools to make parts piece of it here. We don't at this time have a welding program. We don't have a shear and a brake so that you could do something with sheet metal. What we do is take big chunks of steel, typically round, and make bearings and shafts and all kinds of parts needed by industry. We start out, we actually have some manual equipment. We have some milling machines that look like a drill press, and they're not. We have the engine lathes. The students learn that simple thing. They come into the computer numerically controlled machines that are huge, and they do all of this stuff by themselves. And that's the world of industry today. If you go to any state-of-the-art manufacturing, from a Boeing to a Halliburton, that's what you're going to see, are those very the machines. And you don't touch those parts. That's all done inside of a closed case. What the students learn to do is run the computer that not only creates the part, it also continuously measures it and does quality control on it. And when it gets out of tolerance, it shuts the machine down and says, you got a problem here.
And that manufacturing is such a vast.
It is a broad
several
area.
Jobs that students could, and that's a lot of jobs out there.
Oh yeah, huge.
Okay. What about, let's
do power plant.
You want to drink?
No, I'm okay. Let's do power plant.
Let's-
Yeah. Our power plant technology program.
Again,
Oh, I'm sorry.
I was in the middle of a Zoom.
Oh, I hate that.
Okay.
Our power plant technology program is brand new. It just started this fall. It's kind of interesting how these things evolve. The gentleman with American Electric Power, AEP, out of Columbus, Ohio, contacted our president and said, we're having issues finding people to replace our retiring power plant operators, which is a bad deal for us. We don't want to see any of those shut down. I like my air conditioning in the summer. And so we collected a group of people who have responsibility for power generation, not just in Oklahoma, but across this region. And we convened a summit and set them down and said, what are you talking about? Tell us what this person would look like. It was important enough that we actually brought in an expert from Ohio State University and did what's called a DACUM, or Design a Curriculum. That's an acronym. And they spent several days in a room really spelling out exactly what we needed to do to produce this person who's going to operate or run the power plant. And after the result of that is we have a curriculum that is totally industry endorsed. The challenge then was to find an instructor. One of the things that we need to talk about, our instructors here are all degreed, but they also have spent many years in industry. So they don't just bring an element of education, they also bring all of this practical experience. And it also gives us all the ties to industry. So then we had to find a power plant technology instructor. And we found out that those folks make substantial amounts of money, a whole lot more than we pay teachers. And we were very fortunate. We found a gentleman who had just retired from the United States Navy as a power plant operator, and he had actually taught the last several years he was in the Navy. So he was ready to hit the ground running, and so he's done a great job. We're in our second semester, full semester of that program, and it's the interesting thing to watch, a brand new program, is those industry partners come to campus and are getting acquainted one-on-one with those students, because they want those students to understand that no matter what the economy does, period, somebody's going to run those power generating plants. We are going to pay our utility bills, and we are going to want our electricity when we turn the light on. So that program is, even though it's brand new, it's flourishing. An interesting thing, a power plant advisory committee or steering committee met last week, and one of the companies donated a very expensive training tool, and it's a boiler that actually boils water, creates steam, turns a turbine, which turns a generator, which generates AC or DC electricity, and then has a little cooling tower. Now, this thing is very, very expensive. But you know, I can talk all day long about what a boiler is and what a generator is and what a cooling tower is. But when you can stand there and touch the thing, it makes learning all totally different. And it was just an awesome donation.
That's awesome. We'll have to get video of that class.
Yep.
Okay.
You want to do nano now?
Well, if you're ready, what about instrumentation
Well,
engineering?
EEI is kind of a continuum that goes into the BT degree. I mean, that's fine, I can
Well,
do.
we can do nano.
Okay, let's do nano. That won't take too long. Oh,
That sounds like the most, like,
well, it is. It is. It's the ultimate nerd degree, you know.
yeah.
We have a nanotechnology program here, and it's an Associate of Applied Science in Nanotechnology. And people think about nanotechnology, and all they think about is a PhD with thick glasses and a lab coat, you know, doing something molecular. Nanotechnology is all about little stuff. You know, a nanotechnology, a nano particle is a billionth of a meter. So it takes some pretty good glasses to see something a billionth of it, and that's an atom. That's what you're looking at. But everybody forgets that in places that use nanotechnology in the real world, they don't want the PhD operating the atomic tunneling microscope. They would like a technician to do that, and that's where we come into the program. We were very fortunate and received a National Science Foundation grant to help us buy that equipment. We actually have an atomic tunneling microscope that you can actually see an atom and a molecule with, which is pretty amazing stuff. But if you're going to do nanotechnology, you have to have that equipment. That's what our students need to learn how to operate to be valuable to industry. Go ahead.
What kind of careers could, I mean, that's awesome.
You know, my first question when I saw that, when I came to work in this division, was, okay, there got to be at least 2 companies in the world that need to hire nanotechnicians. Yesterday I was on a conference call with Jim Mason. He's head of the Oklahoma Nanotechnology Initiative, and we're going to actually go and make a presentation at one of their meetings, and they expect 200 people in attendance. So nanotechnology actually is a pretty big deal. Most large companies are doing something with nanotechnology. Paint companies are using nanotechnology to make their paint stick better or make it less resistant to the sun and to oxidation. So nanotechnology is starting to become a part of all of our lives. There's a company here in Oklahoma that creates nanotechnology clothing that they treat with a nanoparticle so that no matter how long you wear it, it doesn't smell. Now, you'd think their primary market would be college students, but in fact, it's the military. They ship that stuff to Iraq. I mean, you're in the desert, you can't bathe every day necessarily, and so they're using the socks and those clothes. So nanotechnology, there are a lot of jobs out there for our students. Kind of if there's a downside to nanotechnology, it is pure science. So if you don't love science and math, you don't want to do nanotechnology. And but there's good paying jobs for people that do like the math and the science and get that degree.
What are some of the things that students are actually looking at and experimenting with, and do they
Here?
have other equipment too?
Yeah, we have actually we have a whole laboratory, and it's not a huge laboratory, but the equipment is horribly expensive. when you think about biology, when you look through a microscope and you see a cell, think about something that cell is a millionth that size. Just finding that cell becomes a huge ordeal. And so, how do I find that carbon atom with that atomic? That's a whole science into itself. And so we do, in the intro class, they do kind of the what's it all about, and we're going to scare you away a little bit with all this math and science. Then we go into characterization, and that's where we have samples of all kinds of nano products. And of course we have that famous carbon nanotube that everybody, and that's kind of the building block of nanotechnology today. We don't do anything with microbiology or nanobiology. That's a huge area, and we may someday, but we do characterization of material, and we do the hard science part of it. But it's a fascinating thing to watch. Actually, it's real boring to watch because they don't move a lot, and they use a microscope that's got a huge computer attached to it. But it's real rewarding for the students because once they learn to do that, the processes involved in nanotechnology, that's something that they can take to industry and sell for a lot of money.
Wow, that's great.
When I was looking at it, it was,
One with the HMI?
Yep,
Okay.
yep.
And the wireless, the Delta V, does that,
Yep.
which programs?
Electrical instrumentation, yep,
Okay, so
yep.
let's just go ahead and talk about that and just be like you did for one of the ones, just kind of a
Broad,
general
okay.
definition
Okay.
of that program.
Are we doing it? Okay. The kind of the oldest piece of this division that's left is the electrical electronics. If you'd have come here 50 years ago, we had an electrical electronics program here. It looks very different what we do today. Remember that?
I'm getting mic interference.
I'm sorry.
I'll stand down.
You ready? Okay. No?
No problem.
Okay.
Okay.
I'm rolling.
Okay. Start again? Okay. The electrical electronics program is the oldest program in our division. It's been here since the school was here. If you'd have come here 50 years ago, 40 years ago, still doing
I'm
it?
just going to change the mic out.
Oh, okay. We cool? Okay. Let's talk about scholarships for a minute.
Okay.
We have scholarships that we offer. Until recently, those were offered through the division offices, and we didn't do a very good job of managing that process. And so these are all offered through a newly created scholarship office that's part of the admissions process. So students that want to come here and be part of us, if you're right out of high school, you do the application and send your high school transcripts and all of that and apply for scholarships. You have to still fill out a form. People that come here that transfer in from other institutions, there's a little bit different process. We need to see your transcripts from where you came from. But we do offer scholarships, and we have about 750, 800 dorm rooms on this campus. So everybody else drives to school every day. So we're still a commuter university, but the people that live in the dorms always spend the most money going to college wherever you go to school because you also have to eat there. But students that are interested in coming here should go to the admissions office. It's in the Grady Clack Center, and you will be led through that process. And one of the people you will talk to is a financial aid counselor, and they're the folks that do the scholarships.
There's probably a whole video to make about that too.
Yep, there is.
Okay, so we were going into instrumentation.
Okay,
and,
sure. Yeah, we'll just start all over there.
yeah, the definition.
Yeah,
of-
well, the electrical electronics program is part of the programs that this school started with 60 plus years ago. And 50 years ago, 40 years ago, if you came into this building, which wasn't here then, you would have seen lines and lines of workbenches, soldering guns, it kind of smelled like solder all the time, and vacuum tubes, because that's what electronics was. I mean, think about what we had electronically then. We had some pretty simple televisions. Early on, they were all black and white. We didn't even have color. And we had radios, and they all had vacuum tubes in them. And you could take a sack of your vacuum tubes to your local grocery store, and there was a testing machine. And so what we did, our graduates worked for companies that literally took televisions apart, replaced components, brought them back to your house. Well, that world is gone. Today, it's plug and play and throw away. So over time, the electrical electronics program moved into the digital age, and today it's a very different place. Now, the electrical electronics is an Associate of Applied Science degree. Everybody that comes to the BT program, or the Bachelor of Technology and Instrumentation, is a product of that Associate of Applied Science. So it's just a continuation of that program. So it's a long word. We say Electrical Electronics and the Bachelor of Technology of Instrumentation. So around here we say EEI. But what those people do is absolutely amazing. The whole world is managed and run by instrumentation. We go back over and talk about design, drafting, and manufacturing. If you went to a large manufacturing facility, a big part of that is instrumentation, because they're monitoring using digital instruments, and most of them are wireless today. They're monitoring everything that happens in that shop, from the light to the inventory to the parts that have been made. You know, we barcode everything and it's scanned. We have fewer and fewer people who want to do technical jobs in this country. So the jobs that are there require more and more technical expertise, but they also pay more and more money. So that's kind of the world of instrumentation. 4 or 5 years ago, we didn't have very many oil companies coming around here. If you think about it, go back 5 years ago, you know, we were paying $1 a gallon for gas or whatever. All of a sudden, gas is at $4 a gallon. Everybody starts drilling for oil. The pipelines are running full in this country. And at our front door shows all of the pipeline companies and all the oil companies wanting to hire our instrumentation graduates, because they need to upgrade all of their equipment. I mean, we've not been active in the petrochemical business in this country for a long time. I mean, we have that infrastructure, but all of a sudden now it's a big deal. I mean, companies are making large amounts of money and they need our students. We have an oil company that they're in Midland, Odessa, Texas. They come here on their corporate jet very frequently, and they form relationships with our students. They get to know them, and then just before they graduate, they offer them unbelievable jobs. And they send them all over the world because it's a global company. And they do all of the stuff that we teach here, so our students are immediately valuable to them.
Can you kind of talk about just kind of a broad statement about how the jobs these students in your under engineering technologies that are available to them right out of college are not like entry level, like
Sure.
base pay. Just, I mean, there's tremendous earning potential out there.
Most people don't believe how much money our graduates make. In fact, the parents of our graduates don't believe that. We do a reception before graduation and invite all of the parents and the family members of the students graduating. And the conversations that I love to have with those parents are, Dad goes, I've worked at my job for 32 years and I still don't make what my son or daughter's making right out of this school. It's just staggering, the amount of money. But again, and I've said it several times, it's the fact that we have fewer and fewer people who want to get their hands dirty, even a little bit. And there's a lot of jobs that require that. So the people that are willing to educate themselves and go do that work are highly sought after by industry, and they're highly compensated. And we go back to part of that industry connectedness. As the instrumentation world has changed dramatically in the last 2 or 3 years, we have sought almost a holding hand type of a relationship with our industry, because we don't want to go down the wrong path, number one. We don't have the money to make 2 or 3 mistakes. So we need to know exactly where we need to be with our education programs. And then as we go down that road, when we find very expensive things we need, industry has been very, very generous to step up and say, here, you need this to accommodate the new technology in our students. So that's kind of the thing that makes us unique and makes us really work and makes our students valuable, is we listen to those industry partners. I mean, we really hear what they say. And we don't just have a meeting to have a meeting with them. You know, we're there for them to give us guidance.
Excellent. Okay, and the internships
internship.
are important in
Yep.
all programs.
Our programs are all required to have an internship. And you know, we talk about an internship like the date before you get married. Couple of purposes for the internship. One of them, it obviously gives our student a chance to go show off, because they take their skills and they go to the real world and they work alongside the people that have been doing their jobs for a long time, and everybody can see our product. So we really like internships. It also validates everything that we do here. You know, when a student goes to an industry and goes to work on Monday morning and it looks just like what their classroom looked like, that's a real comforting feeling. I mean, the worst feeling in the world is to go to work and think that you're all prepared and you don't recognize a thing that's around you and know how to do anything. Our students don't find themselves in that situation. So they get to show off. Now, we also, you know, we see their flaws. You know, like if you don't like to get up and come to work on time, that's not a good thing. So when we send our interns out, they go out with stern warnings that you are representing this institution and this program. And they acquit themselves very well. Probably 90% of them come back with an employment contract. Today, we don't just do a job offer. There's so much competition for our students that when they get hired, they actually sign an employment contract. So they know how much they're going to make, and if there's a signing bonus, which is pretty common, and if they're going to move, the company usually pays to move them, and not that it's real expensive. You can pack up most of what they own in a car and drive somewhere. But the internship is just as integral to our program. And it also, when the student comes back from their internship, they're usually in their last semester, and they do a capstone project. And that's putting the period at the end of the sentence. So they do a capstone project, and it typically is something that they saw on their internship. And we invite industry and everybody that we can get to sit down at the table and watch that capstone presentation, which is usually the last day they're here. That's when they graduate, and that's just a huge thing. And so that whole part of that process is so valuable to the student to get them ready to go to work.
Does every program have a cornerstone and a capstone?
Every program on this campus is required to have a cornerstone and a capstone. Mm-hmm.
Okay, and just continuing on with that, just define what the cornerstone.
Sure. Cornerstone is, you know, when I was in school in 1812, we call that freshman orientation or something like that. But every division's cornerstone is tailored to that division. But, you know, we talk to the students about study skills, and, you know, we introduce them to all the services on campus. And we get a lot of 18-year-olds who come here from all over the state of Oklahoma, you know, and they have all of the 18-year-old issues. You know, they lose their boyfriend or their girlfriend, or you know, I mean, all of that stuff. So we have counsel. We have a counselor on campus. We have an awesome library. We have an awesome librarian, and you know, the library looks different today than it did many years ago. It's more digital now. We actually put some of our testing equipment over in the library, so in the evening and on weekends, the students can actually do their homework, because our homework is doing something. So they can actually go to the library and have access to that testing equipment.
Okay, and going back to the internships a little bit, what percentage of the total degree time, you know, this would you say is spent on the internship, and are they paid?
Yeah. Internships, depending on the program, and again, industry is helping us with this. We don't do this in our all-knowing wisdom, you know. Some programs, an internship is one full semester. So they're gone a whole semester. In some internships, they go a half a semester. In some internships, there's a half a semester, say in the third semester, and a half a semester in the fifth semester. It depends on the program. It depends on the industry, how they want to do that. We kind of thought, as the economy is slowing down and we're seeing some economic distress in our country, we thought we may have trouble placing interns, but we actually have more requests for interns by far than we have people to fill the requests. So, yeah.
And oftentimes they're paid internships.
They're all paid internships. I would never send anybody out to work. It would scare you to know most interns make quite a bit more than school teachers on their internship. And again, 20 years ago, internships were very different than they are now. I mean, a lot of those internships were not paid, and it was like a privilege to go get an internship. Well, there's such a shortage of technicians today that intern out of this program actually can take the spot of a technician in the field. So they're looked at and held in very high regard. They're treated very well. They typically come back with an entire wardrobe of logo wear from that company. And they speak with great pride. I mean, that's the part the companies have come to understand, is they need to sell those interns on coming to work for that company as much as we as a school need to sell that company that we're producing a product that they need and want.
Great. Oh, I think we got everything. I just tried to. A pneumatic trainer and people in which program?
EEI and power plant.
A little kind of off axis line.
See, it has air to it. And these things, these are modules. We can pull these apart and move them around and put it back together again. And that's what the students do. And then they hook up the air to it. There's a whole box of the little cords over here, the little hoses that they plug in and plug out through here. Mm-hmm. So, all of that stuff is governed by laws of physics. So we teach them the laws of physics, and then they come here to apply it, which is pretty cool.
Yes. So we'll do some of these.
I didn't even do any close-ups on what we did.
No, she actually had to get I'm serious, she had to get the powder puff out. I had to make it. And I'm not occupied Saturday night, so.
We got a picture made of it.
That's right. Hey, they took a picture of it.
Oh, we got some plexiglass lenses if you need it.
Yeah, well, it's been talk about it, Kristen Holiday was just kind of out there, loosening it up and just kind of doing it. I'm gonna kick you back out, so because it's all the last.
I was gonna say, if you don't do that, it doesn't fit in the cases.
Yeah, it won't fit in, no, so
Yep. Backpack. I was ready to throw that camera gear away about halfway up.
that's right. In there.
And you don't think a little old camera gets heavy until you carry it right up the side of a mountain for 8 or 9 hours.
Well, I noticed, I heard on the news this morning that the highest mountain in Antigua, we were working on this the world's biggest on-the-job learning.
It is.
There's no like school to go to.
Nope.
Train to be president.
Well, we've discovered over time that he's a senator, but governors have actually a better shot at being president, and that's because they are a junior type executive. But
Well, they had governors in the run, but the governors didn't.
they didn't make it. But nobody will weep for them and haul them away in handcuffs. Arrogant person. I mean, he was the least bit humble.
What makes him so fun is he's kind of.
He's got sort of flapping.
Well, sure, one of my big fancy mind went.
All to maintain, and those things are so full of bugs. It's just part of that system.
My son's studying broadcast audio engineering and also technology, so that's putting bone up for exam. I thought, man, these guys are really teaching, really good stuff.
Yeah.
Yeah, he learns it.
Well, that's, there's I can't tell you his name right now, America. And he had a degree, he had an engineering degree in audio engineering, and he had 2 or 3 degrees. He had a degree in architecture. And he just picked the jobs that he wanted. No. I could imagine yesterday, you got it at my age.
No.
That doesn't,
I heard you wanted to go.
Yeah. I mean, you know, it's been several years ago. We went to see Sinbad. He was at the Union Performing Arts.
Oh, yeah, I remember that.
And I'm not high on hearing a lot of comedians in person. They typically get really rude. You could have taken your grandmother. There was
Is that
not
right?
one. There was nothing.
Did it. You got one more, yeah, well, that goes there.
Yeah. And we call that one a finger getter.
Which one? Oh, yeah, that one.
That old one?
Or there's a lot of pictures of people with it.
That's pretty clever. MacGyver is.
Most brilliant thing in any production, and people always ignore, because too late is all. The picture is very easy to do.
Oh, yeah. Well, if you watch them do it professionally, they have those boom mics that they don't like them. They actually all over people's. And if that's not important, then they're actually recording that on a separate device a lot of times. And they mix it, yeah.
And you just look at, you know, what was the one thing, and then you talk about it. It's also the thing that really sells a movie, like a movie in a theater.
Oh, yeah.
What is it that makes it jump in?
All the music and the sound, absolutely. You can't hear the actors and the.
He can do a pretty good imitation too. These, just, you know, the wires inside, the guts over here.
Yep.
But I'm gonna mix them with the backgrounds. and
I was gonna
stuff.
say, yeah.
Oh, I see, you're thinking of using these for backgrounds, like a PowerPoint, and then you lay the
Video.
words and stuff on top of it.
Yeah, or, like around when it opens and it kind of like the Komatsu just had like a moving background, and I actually had thought to put pictures on top of that, but it turned out that the bulldozers and that background together
Yep,
looked so good
Yeah,
that it
they
didn't
did.
need anything
it was good.
else. And I can do something like just really high-tech looking like that for, and then if we wanted to move stuff around on it,
Yep.
we can.
Pinnacle is what my wife uses.
Oh,
But,
it was, yeah.
we just got a new computer last week.
Would you want?
We had one made.
Oh,
I have a terabyte of memory. 500 gig hard drives. I mean, that's pretty common today. But if you do this stuff, we bought a really expensive audio card. It's got a ton of RAM on it. Because that's the next model
Right,
back.
that's exactly right. And your video card.
Yep, your video card.
I did one on that church mission trip. I shot a bunch of pictures on that trip. But then there were other churches that were there elsewhere.
Okay.
They posted all their full frame pictures on theirs.
So you went and captured it?
Used a phone recorder to record the tape.
Uh-huh.
So I had all these interviews that had kind of a radio sound to them.
Exactly, that's kind of cool.
Yeah. And then put in music,
Yep.
the slides. I think it really neat.
That's awesome. That our 6-year-old granddaughter.
It's pretty amazing.
We have a Kodak, really good Kodak photo quality printer, but you don't do a whole lot of that. It's really expensive. You use Kodak paper and the high quality inks. You can email your digital stuff.
I know, it's amazing.
It
yeah.
is amazing.
I like
They
Walgreens.
can-
The only hang up is we have to get the right aspect ratio and
Yep.
cut off part of the photo.
Well, Marla always edits stuff. I mean, still she uses Photoshop. But she learned to do that when she worked for the World, and she's really good at that. I know how to open the program, you know.
Last time,
But, Floyd Osborne taught it. He's a retired professor over there. He showed us one that Governor Henry had made by somebody in the state government. And it was so busy at the end, he said, now what is that about? And nobody in the class could tell you what the topic was.
yeah, that's one thing I find is,
his. Not a go.
Oh, I gotta see that.
Me? I've got a little demo on my
Yeah,
computer
let me
I
see.
made.
So he talks to you,
He talks to me. I mean, I'm making, you know,
you
it's,
tell him what to say.
yep, it's all scripted. And I've got a remote control in my pocket, so I'm controlling when he does that.
I wanna see
You'll
that.
see that?
When you need to go, Kristen, we're,
Alright, are you finished with me?
yeah, we're finished.
Thank you.
You're welcome.
Tracy, I'll be back in a flash.
Okay, I want to see it.
Oh, you wanna see?
Yeah, I'm coming.
He's got to see.
Hello? Hello? Okay. Shooting, yeah, we just finished the interview. So, I'm shooting close-ups of circuit boards. I was gonna blend them with the backgrounds and yes. I definitely need them by Friday. Okay, well, thank you.